Hey everybody, it's Jane from Norman S. Wright. In last week's video, I talked about VAV box minimum inlet CFMs, and there's another minimum CFM I'd like to talk about, and that's heating CFM, especially when you have electric heat. So let's get started. You can have hot water or electric reheat on VAV boxes. With hot water reheat, too low minimum CFMs will affect heat transfer and comfort. With electric heat, too low minimums can actually cause safety issues or damage coils. So let's move this up and look at this. Let's draw a VAV box with electric heat. You have the inlet, the casing, and we'll put the electric heater here at the end. With electric heat, it's important to have adequate airflow across the electric coils to avoid hot spots on the coils. If you look at the damper position at minimum heating CFM, it might be kind of closed like this. So airflow will come off the damper and be directed towards only part of the electric coil. This is the reason that electric heat VAV boxes usually have longer unit casings. This extra distance allows the airflow to have time to spread out before it gets to the coil. Per UL, VAV boxes with electric heat have to have thermal cutouts and an airflow proving switch. And make a little bit more room again. The thermal cutout will switch the heater off if the temperature it senses is above a certain temperature, which I believe is 125 degrees Fahrenheit for single duct VAV boxes. The airflow proving switch won't let the coil be energized if there's no airflow. You can also get hot spots on the electric heater element, which will trip out the thermal cutouts. So you need to make sure that the VAV box minimum is high enough that this won't happen. Let's move this over again. The equation for electric heat is kW equals CFM times delta T divided by 3160. Or CFM is equal to 3160 times kW divided by delta T. So we can calculate the minimum CFM for 1 kW that gives a 125 degree discharge temperature, which is the temperature that'll trip the thermal cutouts. And let's say we have 55 degrees supply air. So now we have CFM equal to 3160 times 1 kW divided by 125 minus 55, and that equals 45 CFM. So this is the minimum CFM to not trip the thermal cutouts. You really don't want 125 degree discharge air from your VAV box. Air this hot will stay at the ceiling and won't make it into the space where your occupants want heat. ASHRAE 62.1 recommends less than 15 degrees delta T supplied into the space. So for our 75 degrees set point, this is 90 degrees supply air into the space. So you want maybe 95 degree discharge from the VAV box. So let's move this over and look at this again. In a single duct box with 55 degrees supply air, the CFM is going to equal 3160 times the 1 kW divided by 95 minus 55. So that comes to 79 CFM. So let's just round that up and say a good general rule is 80 CFM per kW for your minimum heating CFMs when you have electric heat. As always, you can ask your Norman Wright salesperson for help selecting VAV boxes and minimum CFMs for electric heat units. If you have any questions or suggestions for future videos, put them in the comment below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and we'll see you next week.